Welcome back to the final lecture of this fantastic afternoon. It's really, for somebody, I'm a historian of mathematics, and so this is a whole new world for me, which is being opened up in front of me, so which is great. So I'm delighted to introduce Prof. Haigh, who is probably known very well to many of you here. He's a professor at the University of Wisconsin-Milwaukee, but he first studied at the University of Manchester with a degree in computer science. Then he did a PhD at Penn in history of technology, and he's currently chair of the history department. So a very varied CV. So we very much look forward to your talk, Tom, on artificial intelligence, the brand that we can die.
Oh, thank you. Thank you. So I am going to be talking today around a book project that is nearing completion, should be going off for review next week, Artificial Intelligence, the History of a Brand, for MIT Press. I'd previously written about many aspects of the history of computing, including this big book here that tells the whole of the history of modern computing from ENIAC 1945 through to 2020. And one of the things it doesn't do really is mention artificial intelligence, which, as it turns out, these days is the only thing that anyone wants to know about. But there's a reason it doesn't really mention artificial intelligence, and that is that it's a book about the history of computing practice and technology. And until recently, while AI has been very important in the history of computer science, it hasn't done very much going out into the world and actually doing stuff. Now, clearly that's changed now. So I have written a book about the history of AI from 1955 and the introduction of the term through to sometime last week. And one thing I want to say at the outset is that this is a short history in both senses of the term. So it's literally a short book, but it's also a history specifically of stuff that's been called AI by the people who did it, and a little bit on things that aren't called AI anymore, or things that didn't used to be called AI and started being called AI. And that's a distinction from what a lot of historians involved with this kind of thing are doing, which is long histories where they say, oh, let's trace the history of AI back to Charles Babbage or Frankenstein or ancient Greece or so on. So you see a contrast there with David's talk, which is expanding the idea of AI and looking at the roots and so on. And clearly both kinds of historical projects are valuable. I do think that there's a use in charting what AI has actually meant to different groups of people and how that's changed over time. Because anytime you tell one of those broader histories, you're imposing your own analytical definition of what you think AI means and saying, although this person in this historical thing didn't think they were doing AI, we now see that this is part of the history of AI or the genealogy of AI. So that's what I'm particularly concerned with. If you find this talk interesting, and a talk, even a relatively long one, can't really be more than an advertisement for the actual work, then I'm pleased to say I've already published a series of 5 pieces in communications with the ACM, which give an even more compressed version of the history of AI, totaling about 20,000 words. What I'm saying today is going to be mostly about this first era here in terms of detailed history, the invention of AI and computer science together. And those are all open text, easily available. So I encourage you, if you like this talk, to go away and read them. So explaining the title, actually, and this is rather similar to what you had, we do have something interesting going on with AI. So there's an initial AI boom that is occurring there 1980s. And then discussion of AI in this gigantic corpus that Google has so thoughtfully digitized slumps down and doesn't really recover until the latter part of the 2010s. But then whoosh, oh my God, does it recover, right? AI suddenly becomes so talked about in the last 5 years that it completely eclipses all previous eras of AI hype. So there's something that needs to be explained there historically, right? Why does discussion of AI peak, decline, and then suddenly come back much bigger than ever before? And I'm going to give you the answer to that right at the end of the talk to just keep you guessing. another little bit of scene setting here. I'm sure you're all familiar with modern day AI hype. If you haven't looked at the history of this, you might be startled to the extent to which exactly the same claims and predictions with very similar timelines that are being made today about what's going to happen in the next 3, 5, 8 years were made previously about what they thought would happen in the next 3, 5, or 8 years. So Herb Simon, Nobel Prize winner and Turing Award winner, right? Not a crank, not an ill-informed person, in 1960 believed that it would be surprising if within a decade, the problem solving and information handling of the brain hadn't been completely duplicated by machines. Turing Award winner Marvin Minsky agreed. And in fact, in 1970, Minsky was quoted as giving a 3 to 8 year horizon for the time for a machine with the general intelligence of a human being, which could do things including reading Shakespeare, playing office politics, telling a joke, have a fight. And there's the other half of the claim that you see a lot these days too, the singularity kind of idea. Once you reach that point, it's not just going to stay as smart as a human. That's going to be a very brief period because it's going to improve itself and very quickly become a godlike genius. And that's basically the end of the human era. I think the same article included the quote that if we're lucky, they'll keep us around as pets. Now, there's also a previous era in which AI was associated with business startups and with big companies starting AI groups, and that was the 80s, that earlier peak, particularly around the idea of expert systems. And the promise was that these promoted such revolutionary change, productivity improvements of a factor of 10 or more, that companies had to rush and implement this technology now, otherwise they'd be permanently left behind by their wiser competitors. Bit of AI hype now, right? As you know, every year since 2016, Elon Musk has promised that by the end of that year, Teslas are going to be working commercially as robo-taxis and fully self-driving. 2 years ago, all the leaders of major AI companies had timelines for AGI that were 4 years, 5 years, 2 to 3 years, the next few years. Elon Musk, I think, was promising the next year. Then 2023, there was the remarkable statement issued by everyone who was anybody in AI, warning us that AI posed a risk of extinction alongside nuclear war, pandemics, global warming, which is unusual, right? The tobacco industry didn't take out ads warning that it was liable to kill us. So there's something unusual going on there that I think needs some historical explanation. Companies have already started blaming all layoffs on AI, which sounds much better than blaming them on not being very good at business. In terms of money, right? I mean, I could spend the whole talk just talking about this, but OpenAI last year had the biggest ever single round of venture capital, $6.6 billion. It raised $40 billion, smashing that record about a week ago. But OpenAI, its leader, Altman, claimed to be seeking $7 trillion, right? And you know about numbers, right? That's an extra 3 zeros. That's like not quite all the money in the world, but it's a pretty substantial chunk of it. Saying that's how much money they'd need to build the custom chip factories, ramp up the data centers, and truly exploit the potential of general AI. And they made that pitch to Saudi sovereign wealth fund and so on. And when you look also at the fact that the value of the biggest companies in the world, like Google and Microsoft, has doubled or tripled based on claims about what they're going to do with AI. These predictions are moving a very large amount of the money in the world over the last couple of years. Here in Britain, of course, you've got a 50-point plan to fully exploit AI in government and fix all those problems. In the US, there was some kind of weird photo opportunity in the Oval Office and a talk about spending $500 billion on something or other. So, that is the present day context. And again, the fact that very similar predictions and very similar timelines were made more than 50 years ago doesn't mean those predictions are wrong now. As a historian, you can't say that, but it is certainly instructive to know that there is a history of making exactly those claims for what's going to happen and knowing what happened with that in the past. So the first part, I'm going to talk about the origins of AI basically the 50s and early 60s. Then instead of going slowly through the whole history, which is going to keep us here until sometime tomorrow morning, I'm going to jump forward and talk a little bit about why I call AI a brand, and in the process, sketch some pieces of the intervening history. Then right at the end, I'm going to answer that question I've been tantalizing you with about why AI wouldn't die, and make a few comparisons, literally one slide, AI then versus AI now. So the invention of the brand. Now, there's something underpinning what I'm going to say here, and I don't think this is going to be radical to you if you know anything about AI. Sometimes it surprises general audiences. So sometimes people assume that there's something coherent about AI that has changed the same over time. And what we say now when we mean AI is the same that people meant 50 years ago, and that isn't true. And the other thing is that there's some inherent connection between the technologies that get branded as being AI and human cognition. And I may be offending one or two of you, but I don't think that's really true either, by and large. So you perhaps wouldn't be surprised, therefore, to know that the origin of the AI is not the first time that people start talking about computers as being brains or computers thinking. In fact, that is an older idea. Some people with the long history of AI go back to Babbage and so on in that kind of context. I'm comfortable certainly going as far back as John von Neumann's first draft of a report on the EDVAC, the first description of modern computer architecture. And von Neumann at that time was hanging out with people who were basically inventing cybernetics. They didn't quite come up with the cybernetics brand yet. At that point, they wanted to found something called the Teleological Society, but it was basically the same people, the same idea. As a result of which, see, everyone talks about this paper, but no one reads it. If you go read it, you'll find it's much stranger than you think. And one of the strange things is that von Neumann doesn't talk about storage and memory and so on as being subsystems. He talks about them as being organs. He talks about logic gates as neurons. He talks about them being stimulated and excited, etc. And this is very much that proto-cybernetic approach. So the idea that the computer is doing something very brain-like is not some like weird idea that you need AI people to come along and do. It's right there in the original document describing the modern computer. And if you look on the popular side, the first book describing to a general audience what computers like ENIAC and the Harvard Mark I and so on are doing is this very popular book by Edmund Berkeley, Giant Brains or Machines That Think, right? And it's pretty much there in the title, right? I don't need to stress this one. But remember, this is the year before Alan Turing talks about the imitation game. This is 6 years before the term artificial intelligence is introduced. So the public is being introduced to computers for the first time, literally as thinking machines. And the idea there is basically that they're made of switches. Neurons in the brain are also switches. The thing is switching itself automatically, so therefore it's a brain. And the end of the book has got this weird piece of rhetoric that just seems so topical. So Berkeley is worried about physical safety from the computer uprising, and he's also worried about technological unemployment. But if we can overcome those two threats, we'll be free from the threat of the robot machine and welcome the robot machine as our deliverer from the long, hard chores of many centuries. And you've got that same rhetoric now, that AI is the most important thing in the world, that this huge historical rupture is coming up in 2, 3, 4, 5 years, and that the choice is either going to be the machines wipe us out or some kind of post-work utopian, human transcendence. And just to drive home what a minimal definition Berkeley had for a thinking machine, he explained how you could use a few relays, a cardboard box, and some light bulbs to build your own homemade paper tape-driven system, which would be a very simple mechanical brain, and had a business selling kits that were slightly more complex mechanical brains. So in 1955, when the proposal is written for a Dartmouth summer research project and the term artificial intelligence is introduced, this is not the beginning of the idea that computers and brains are kind of the same thing, or that computers can think. That's where I'm going with that. In fact, it's kind of something a little bit more interesting. About 20 people attended that, and you see a couple of them here. So you've got on the back at the right, John McCarthy, and next to him in the middle, Marvin Minsky. Not shown on the picture are Herbert Simon and Alan Newell. And those 4 people collectively were memorialized as the founders of AI. over the next couple decades. So we've got the proposal here, and they just drop the artificial intelligence problem right in. But that appears to be the first time the phrase is used. Now, two of the people who put the proposal in, Shannon and McCarthy, the previous year had done an event called Automata Studies. So they tried that brand out and they weren't very happy with the results. And this time they're trying out artificial intelligence. And you look at the definition of the scope, it's kind of interesting. So one thing you'll see immediately, number 3 there in the middle, neural nets. So neural nets are explicitly there as part of AI in the definition at the beginning. Then we've got things that are kind of AI-ish, like natural language, number 2, randomness and creativity, number 7, and self-improvement, which is basically learning, which is 5. Then you've got theory of the size of a calculation, which is definitely something computer scientists come to care about, but is not at all seen as part of AI. So the initial definition of AI is rather broad. And what they actually mean by AI, well, we already saw in David's talk that Shannon had been interested in computer chess for some years. So one of the things they pick up on as something that would be intelligent if done by a computer is playing chess. The other thing which Newell and Simon are already working on is proving theorems. So those are probably the two biggest examples there. But they kind of think of this as a general thing. We need to make a computer that's intelligent. If we can get it to do a couple of the things that we associate with particular intelligence in humans, then we can safely say that the machine has mastered intelligence in general. So these are seen as test cases, but they're not seen as narrow, isolated things. The assumption is that the same things that would make a computer able to play chess well will let it do a whole bunch of other things as well. And there's a phrase there in the closest thing they have to a definition of intelligence here, solve kinds of problems now reserved for humans. So that becomes kind of a cliche about AI, that AI is programming computers to do things that no one knows how to program. And when you do know how to do them, they're not AI anymore. And it's interesting to see that's there implicitly right back at the beginning, that intelligence is only problems already now reserved for humans. So solving a numerical equation, say, that a computer can already be programmed to do is not intelligence. And that's a departure, as we see, from how Berkeley was viewing anything that computers do as by definition thinking. So the interesting thing is the origin of AI as a brand is actually not the introduction of the idea that computers are thinking, but a narrowing to say computers aren't currently thinking, but we think we know how to make them do stuff that's smart. And of course, where are the idea of what counts as smart coming from? It's basically a group of young, arrogant, brilliant, predominantly Jewish men who are doing well in the post-war meritocracy of the emerging military-industrial complex and have backgrounds in mathematics, looking around at each other and saying, like, what makes us respect each other? And proving theorems and playing chess are two of the things that get you credit in that kind of environment. There's another cliche about AI that the hard stuff turned out to be easy and the easy stuff turned out to be hard. And chess is one of those hard things that turned out to be easy compared with a lot of other things that humans do. You see also in the famous line that Herb Simon is said to have delivered to his students in early 1956, before the conference happened. Over Christmas, Al Newell and I invented a thinking machine. And they were talking about actually manually trying out an algorithm to prove a theorem. So a computer would not be thinking if it was doing other things, but it would be thinking if it could be programmed to prove theorems. So wrapping up this, the AI agenda of the 60s to 90s, so let's have whoosh, right, fast forward here. There's some continuity there. Intelligence is things that computers currently cannot do that humans that we respect can do. The symbolic approach is institutionalized at the expense of the neural network approach. So what that means is computers manipulating symbols representing knowledge about the world according to algorithmic rules. In the early 1980s, all mention of connectionism and neural networks had been purged from the dominant AI textbooks. Search was the core technique, and there were efforts to find general purpose reasoning methods that could work across tasks and to discover those with sample problems like chess. There was an assumption that the human brain was also a symbol processing device that just happened to be squishy and made out of meat, but that's at a high level of abstraction. It too was doing discrete mathematics, basically. And by the 70s, there was an increase in recognition that you can't just work with predicate logic statements about individual facts, that you need some kind of structured way of representing knowledge. And there's much more of a shift self-consciously in the AI community towards knowledge representation, in part in response to growing criticisms of AI's failure to deliver on its promises in the 1960s. The thing I focus on here that I think is not as generally appreciated outside computer science is the extent to which AI was just fundamentally intertwined with computer science as it grew up. So in the late 50s, early 60s, AI and computer science are coming to existence at the same time. There are no computer science departments, in 1955. By 1965, there are. By 1968, there are PhDs in computer science. So it's a new discipline that's assembled out of bits and pieces of other things. I think of computer science as a federated discipline because there isn't a really sort of strong core. There's a bunch of different communities with largely distinct interests that collectively make up computer science. And AI becomes one of the most prominent and high profile in the 1960s of those subfields of computer science. One way you can see that is to look at the Turing Awards, right? So computer science, new discipline, looks around, what do other disciplines have? Oh, they have the Nobel Prize, they have the Fields Medal, etc. We need one of those. They start out with $1,000 and a silver cup. Takes a while, like actually they have a surprising amount of success with that whole project. But if you look at the first winners of the Turing Award, winners number 4, 6, 10, and 11 are Minsky, McCarthy, Newell, and Simon. So that's by far the most awarded piece of computer science during that first decade, right? They're selecting as the intellectual high ground that helps to justify computer science as a discipline. Or looking at it another way, those same 4 men found the 3 leading centers for AI research in the US, MIT, Stanford, Carnegie Mellon. Now, today, those are not just the 3 leading centers for AI, they're also the world's 3 leading computer science departments. So the computer science departments that embrace AI early on do achieve, and you can argue about causation and correlation. MIT and Stanford also have unparalleled access to federal money on exceptionally easy terms. So maybe this would have happened anyway, but you certainly can't argue that there's a correlation between elite computer science and artificial intelligence during this period. The Defense Department's Advanced Projects Research Agency is the biggest funder of these, and it gives out money in a rather clubby way because the directors tend to come from MIT and give money to MIT and then go back and get given money by their friends. But that is all explained in the first one. Now, there's just one other historical detail I want to pull out before I move on to the brand stuff. So if you want to find out about the history of AI and you Google it, you're going to find a whole bunch of web pages that are mostly written by people who got their information from other web pages, who got their information from Wikipedia. And one of the things these sources are all going to tell you is that there was an AI winter, 1974 to 1980, which was a broadly based decline of interest and funding for artificial intelligence. And looking at what I've been able to find in terms of actual data, right? So the Ngram, we don't see AI discussion declining during this period. In fact, that's when it, for the first time, overtakes cybernetics as a brand. Membership of the main AI association during the period increases. That's the period where here in Britain, AI conferences are first being held regularly. It's the period where the German AI group is founded, the Soviet AI group is founded. I think outside maybe Edinburgh, at Stanford and MIT, where they might be finding it a little bit hard to get money quite as easily as before, there is absolutely no evidence I found for a broad-based slowdown of AI during that period. That's also in one of my CACM articles. So wrapping this up for the detailed history part, AI researchers achieved a lot in the 60s and 70s, right? I don't think I'm giving anything away when I say they didn't deliver on those promises of intelligent general purpose computer systems. They made some apparently promising lab demonstrations, none of which scaled up to do anything particularly useful. And they laid the groundwork for solving some specialized problems like chess, but as David said, in a way that shed absolutely no light on how humans play chess. But in failing, I also want to do justice to this part. Because AI is so entwined with elite computer science during this period, it contributed to many aspects of modern computing. So at MIT, where they pioneered time sharing, that was part of something called Project Mac, which included a lot of AI stuff. McCarthy was a very influential early proponent of interactive computing. The AI language Lisp pioneered important concepts found in many modern programming languages. AI-branded research at SRI created the A-star search algorithm, which underlies, for example, Google Maps. And AI has also, I'm going to touch on this in slightly more detail, and that goes with Anne's talk, got an important relationship with some aspects of modern speech processing. Right? Okay, so why do I call AI a brand? Because you may, hopefully I lured you in here with that, intriguing title. Well, one thing I want to emphasize is that from my viewpoint, calling something a brand doesn't make it trivial. And if you're a computer scientist, you might think brands don't matter. But can anyone tell me who this guy is? Yeah. Yes. This time last year, he was the richest man in the world. Him and Elon Musk were trading off for a while, Bernard Arnault. And LVMH is a wrap-up of most of the world's most famous luxury brands. So the way to be the richest person in the world at the moment is either to do AI and big tech or luxury brands, right? Those are the two things that have been exceptionally successful in getting money these days. I also want to say, it's not that something is or isn't a brand. Lots of things have got brand-like qualities, right? So I identify with the history of computing brand, which unfortunately does not sell particularly well, but we do our best. DEI, like powerful brand, recently fallen on hard times. Or of course, the Ivy League, or more locally, Oxbridge, very powerful brands, right? Enormously desirable. So in that sense, all academic disciplines and subfields are brands. But I'm going to talk in this section about why I think looking at AI in that way is exceptionally productive, in part because it's unusually vague about what it actually means, and in part because you've had these major discontinuities over time. So one of the things brands do is sell things, but I want to emphasize AI, particularly historically, was not primarily a mass market consumer brand, right? What AI was selling, for example, was research projects to funding agencies, or it was attracting smart PhD students to particular labs and degree programs. In the 80s, in the current moment, it's also very much been about selling startup companies to investors, research groups to companies, and funding initiatives to national governments. Brands also demarcate ownership, right? Literally in the case of this cow here. Metaphorically, that's why we call brands brands. And you might think there's a difference there, that commercial brands tend to be controlled by a single company. McCarthy himself later wrote that one of the reasons for inventing the term artificial intelligence was to avoid escape association with cybernetics. I wish to avoid having to either accept Norbert Wiener as a guru or having to argue with him. So they didn't want cybernetics. They toyed with automata studies. They settled on artificial intelligence. And I'd say it's not owned by a single institution, but historically, AI was owned by a small cartel of institutions able to set its scope and agenda, primarily MIT, Carnegie Mellon, and Stanford. So you've got a nice quote there from Pamela McCorduck in the first book on the history of AI, which emphasizes the extent to which those three institutions continue to dominate the program there with the founders and their students at the International Joint AI Conference. I also looked at the first 7 AI textbooks I could find. They had 8 authors, all 8 men, had degrees from MIT or Stanford. Then I fast forwarded to look at the inaugural fellows of the American Association for the Advancement of AI. 54 fellows, 15 were associated with MIT, 19 with Stanford, and 13 with Carnegie Mellon. Now, today, who dominates the AI brand? Who gets to define what is and isn't AI? I'd say it's like probably 5 companies. Right, a lot of brands, particularly luxury brands, are aspirational. So any of you ever read The Economist? So you probably, like me, have seen a lot of ads for Patek Philippe over the years, right? And if any of us ever become spectacularly wealthy, we'll probably decide it's a great idea to spend, £50,000 on a watch because, you're just establishing an heirloom, looking after it for the next generation. It sort of makes sense, right? So that branding, it kind of like sinks in over the years. And I think to an extent, the entire project of AI is aspirational, right? I mean, one thing you've got there it's a discipline that's named after its unattainable objective, right? It's like if we called economics universal prosperity. Maybe they'll get there one day, not yet. Another thing is, it's always needed the most powerful computers, so it's tended to be concentrated at the best funded universities and increasingly the richest companies on earth. Brands compete for market share. And if you follow the engram a bit further, you see AI by the 80s has pulled decisively ahead of heuristics, operations research, automata, cybernetics. Brands impute qualities, right? So you want to get a leather bag, and maybe you're an expert on leather grain and workmanship and all the stuff that goes into great leather. And in that case, you can go to Florence and probably find yourself a really nice one. But most probably, all you know is that Chanel and Coach and other brands that are supposed to be good, and that if you spend a lot of money on those, you're probably getting a decent bag. But also, everyone's going to know that you spent a lot of money. So the brand imputes quality to the artifact in ways that spare us from having to evaluate each thing that the brand is applied to. It's the same kind of way, if something is AI branded research, published in an AI journal, done in an AI lab, we assume it's got something to do with cognition, even if it's probably just a piece of what in Kuhnian terms, normal science, that is like finding a slightly better algorithm to do something that could just as easily have been called operations research or just computer science in general, when you look at the level of what the algorithm is actually doing. Or the same way, you might not know what makes BMWs allegedly drive well, but you know that they're supposed to drive nicely. And brands unite otherwise distinct things, right? So Chanel's historical core thing are the fragrances, like number 5 here, but you can also buy a Chanel watch, a Chanel bag, runway fashion. What does the watch really have to do with the fragrance? It doesn't smell nice, right? But the brand, again, and AI tend to be a slightly random collection of things. Or, for the boys, right? What if the sunglasses really got to do with the car? And what brands refer to change over time. So Netflix doesn't mail you a DVD anymore. Hewlett-Packard doesn't sell you a piece of lab equipment. And the same kind of way, we see from that original broad definition of AI for the Dartmouth conference, a substantial narrowing of the brand to symbolic AI, excluding connectionist approaches, which were branded instead as pattern recognition, deep learning, or machine learning. And then just the last couple of years, the spectacular flip when the AI brand was reappropriated by the neural net people. So AI, like those brands, applied to a discontinuous range of activities. I mean, there's a famous story that's slightly apocryphal that computer vision became part of AI allegedly one day when somebody decided a student needed a summer research project. But other things that could just as easily be thought of as AI, like say Google Maps, right? Why aren't Google Maps AI? I mean, people talk about adding AI to Google Maps, and what they mean is having it make up restaurant reviews based on statistically likely patterns. But why isn't the business of telling me how to get from here to Scotland the most efficient way by public transport an AI problem? And the answer is, back then, no one would have given them money calling it AI, right? And Anne, you had a similar point there in your talk. Why isn't web search AI? Again, in the late 90s, people would give Google money for doing the internet. They wouldn't give them money if they called themselves AI. So I've just got one example of how that works out in practice with the Hearsay 2 speech recognition system, for which Raj Reddy became another Turing Award winner. So that was developed with DARPA funding at Carnegie Mellon in the 1970s. And that DARPA project was AI branded. And therefore, to be funded for it, you needed to say that you were doing AI. You see a clue there in the name of the project. It's called speech understanding, not speech recognition. You see another clue there in the subtitle, integrating knowledge to resolve uncertainty, because in the 70s, AI was all about knowledge. And you see some pretty definite clues here on the first page. That paragraph that I pull out there is citing Newell and Simon and talking about search, right there in the second paragraph. And it explicitly says that the system is a marriage of general artificial intelligence techniques with specific acoustic and linguistic knowledge. So to those people at that time, speech recognition is absolutely an AI project, and that's how they get the money. But speech recognition had previously been done at Bell Labs, for example, And that predated the idea of AI. Then you've got the NLP brand, which is, kind of adjacent to AI, but largely distinct on the academic side. If you look on the commercial side, so Janet and James Baker did their PhDs at Carnegie Mellon, went off to IBM. There was a group there that pioneered the big data approach to speech recognition, not with neural nets, but with hidden Markov models. They were part of that. Jelinek, the leader of the group, famously said that every time he fired a linguist, the system got better. So that is very definitely not about handcrafting knowledge. It's about applying statistical techniques to a large text corpus. And then that technology is commercialized by the Bakers there with their company Dragon. You may remember Dragon Dictate, Dragon Naturally Speaking. So in the 90s, when this is being discussed, people don't talk about it as being AI, they talk about it as being speech recognition. When the company that they produce is bought by another company, there's no mention of AI there. Venture capitalists are interested in funding speech recognition, but this is the AI winter. They're not interested in funding AI. And that company is bought by another company, it's bought by another company, until in 2020, Microsoft pays $20 billion for the company that bought the company that bought the company. And it was called Nuance. And if you go to the Nuance homepage now, they've hidden the products deep away inside. You have to dig for them. But what you get on the splash page is that Nuance is Microsoft's big play into AI for healthcare. And that's why they spent $20 billion. Not that they want Windows to have better speech recognition. So suddenly, after all that time not being AI for decades, speech recognition is AI again, because that's what people want to fund and companies care about. So that's kind of one example of what I mean by that instability over time. So use of the AI brand remains pretty arbitrary today, right? We probably today, if we talk about something as being AI, mean it's got neural nets, or at least it's based on big data. In my university, if someone says something about AI, they almost certainly mean generative AI, particularly ChatGPT and the other systems. But then we still use AI to talk about code for non-player characters in video games, autonomous driving systems that may not be neural net based. But we don't use it for things like Google Maps or web search engines, which, as I said, could just as easily be called AI, but historically aren't, because that wasn't advantageous to the people involved. And brands can be tarnished. So I don't know if any of you remember the sad story of Burberry and the Chavs a few years ago. Basically, the wrong kinds of rich people were wearing clothes that were supposed to be more for old money. And that was a problem for the brand that they fortunately managed to get over. And AI had a similar kind of problem in the 80s, which led to the AI winter of excessively high expectations and people who didn't know what they were doing, claiming to do AI and, etc. So this is the famous description from a 1984 panel discussion that talked about what could go wrong despite the field booming. The Strategic Computing Initiative collapses miserably. That's a funding program. Autonomous vehicles fail to roll. That's rather topical. The fifth generation turns out not to go anywhere. The Japanese government gets out of computing. The startups fail. The big companies lose interest. What I love is that line here at the end. Everyone hurriedly changes the names of their research projects to something else. And that's basically what happened. I mean, companies have been doing some things that they called AI that actually worked in the 80s, and they didn't necessarily stop doing those things. They just stopped calling them AI. Now, that AI winter that was predicted there is real, right? So you see that blue AI line that peaks at the end. You follow it back. It peaks here next to the red line for expert systems. Expert systems go away and never come back. Sorry, Ed Feigenbaum. And AI slumps down, and it and the line there for machine learning, right, mid-2010s suddenly explode. One of the things that's interesting to me here, just like you plot those things together, artificial intelligence is talked about several times more than computer sciences at this point. So that's, and I still think of AI as being a sub-piece of computer science, but I don't suppose the AI companies think of it that way anymore. And machine learning even outstrips it. I don't know if they tell probably a similar joke here to Stanford that maybe this should just be called the Department of Machine Learning and something else. Yeah, I think that's how a lot of computer scientists are feeling these days. So the AI brand is selling better than ever today, right? Even 2 years ago, The Economist found that many companies across industries were mentioning it in their earnings calls to try and boost their stock prices. NVIDIA is one of only 6 companies ever to have $1 trillion market cap. They make the chips that run the AI models in the data centers. Okay, it's not currently the world's most valuable, but it was, whatever, a month ago. And I don't know if anyone has noticed, but interesting things are happening with stock valuations today. No idea why. Must be something going on in the world. Apple down 7%. But here's the interesting thing, right? AI is like the hottest, newest brand that's moving the most money. And it's also an old, tired, discredited brand that made this miraculous comeback. So it seemed now fresher than things like Web 3.0, blockchain, decentralized finance, big data, that were the hot new things. And how did this happen? So that's the question I promised to answer. I'm going to answer that now to wrap up. Well, I don't think anyone's going to argue with me if I say that the current AI hype is associated overwhelmingly with chatbots and generative systems. And of course, the Turing test loomed large in popular and philosophical discussion of AI since the 1950s. Interesting thing I found was the textbooks from the 70s and 80s don't discuss it. And they don't discuss what we call AGI either. They just say, AI is about knowledge making computers more useful. Because they didn't want to be associated with those somewhat scurrilous kind of predictions. And they didn't like the idea that we should define intelligence in terms of the ability to pretend to be human in conversation. Because why would we expect a non-human intelligence to pretend to be human, right? When you think about it, it's slightly weird. But that has made a spectacular comeback with ChatGPT, etc., where the language models are clearly packaged to fool people into believing that they have human-like qualities. And just the clearest evidence I could find of this is this book by Michael Wooldridge, AI person at Oxford University, published just a few years ago. And he says, internet chatbot makes AI researchers groan whenever it's mentioned. They're not interesting, they're superficial. Chatbots of this kind are not AI, right? So AI researchers were explicitly zoning chatbots out of what counted as AI within the last 5 years. And now suddenly, if you say to most people, what's AI? They'll be, oh, it's a chatbot. So why didn't the brand die? Promise to answer it, right? That question, why did the tainted old brand become the hot new brand? And this is unusual. So in my other research, I've looked at the history of electronic data processing and the history of management information systems. And this always happens in computing. There's a hot new idea, everyone gets very excited, then they get a bit disillusioned. I mean, that's the Gartner hype cycle. This is not some like weird, historical idea. It's baked into the industry's conception of itself. More recently, knowledge management came and went. Analytics and big data was peaking, but one day. So in computing, people are always inventing new terms to describe old ideas because no one ever wants to hear about an old idea. It's one of the things that makes it difficult being a historian in that area. So today, the leaders of AI companies are insisting that current AI approaches work. They can give us human-like and superhuman intelligence just by fine-tuning, scaling up, and deploying technologies that already exist, and they just need vast amounts of money, a few years, and infeasibly large amounts of training data. This will result in AI automating most jobs, so we're either heading for massive unemployment or post-work utopia. That singularity thing is going to happen with the system going faster and faster and faster. And so it's also going to become superhuman on a very narrow time scale. Therefore, AI poses an existential threat to humanity. I'm kind of reminded of Oscar Wilde, right? There's only one thing worse than being talked about. But also promises a utopian rupture with our long history of war, disease, and toil. Within a few years, therefore, either salvation or damnation. And whatever we do, we can't look away. This is the most important thing in the world ever. And those promises, as I said at the beginning, are mobilizing hundreds of billions of dollars of big tech spending and generating trillions of dollars of market capitalization. And that, I think, is why they re-embraced the AI brand instead of machine learning, deep learning, big data, because basically of science fiction. Now, of course, science fiction's idea of AI is deeply driven by 2001, where Marvin Minsky and Jack Good were consultants, but it takes that kind of AI idea, puts it into science fiction, and ever since then, the Cylons and Skynet and many other things, right? We know this idea that AI is a fundamental rupture in history, that it might kill us, that it's incredibly important from all these fictional narratives. So the idea that rational, self-aware, superhuman machine intelligence is arriving now, it works with that AI brand. And I think that's why that was suddenly reappropriated. And we can just do a little experiment here, right? So if I was to say to you, large language models pose an existential threat to human existence, or if I was going to say to you, ChatGPT will kill us all, right? You're laughing a little bit, right? You'd have questions. You'd be, well, that's an interesting idea. Can you explain more? But if you say artificial intelligence poses existential risk to mankind, like, well, duh. I mean, doesn't it always? You know, we've seen that play out so many times already. So that is my theory for why the AI brand won't die, that it got revived precisely because of that association with these science fiction narratives. And if you look at those claims that are being made by the AI industry, they are fundamentally science fictional claims that work with that narrative and exploit its abilities. So my very last slide here, wrapping up, I promised you continuities and discontinuities. So at the top, I've got 4 continuities between 20th century symbolic AI and the new kind that is until recently known as deep learning, etc. Hyped needs the fastest computers. It's applied to a fundamentally arbitrary collection of technologies that have only a loose connection with cognition in themselves. But here are the discontinuities. 20th century AI was primarily academic. Today, it's overwhelmingly something that only the richest big tech and big tech adjacent companies can afford to do. It used to be government funded. Now it's investor funded primarily. It was symbolic. Now it's connectionist. It used to be all about heuristic search methods. Now it's about statistical prediction. Humans used to formulate explicit rules, which explicitly coded knowledge. Now the system is supposed to train itself from a mass of data. The knowledge maybe is in there somewhere, but like, who knows exactly where. And whereas 20th century AI, to be a little overly reductive, didn't work, and therefore wasn't really applied outside the lab, these techniques do something, even if not what it's claimed that they do, and are being widely applied on big tech platforms and are out there in the world doing things. So that is the conclusion, and welcome some questions and discussion if we have time.
Thank you very much. Amazing. Really, I'm sure what accumulated lots of questions. Okay, Martin? Yes.
You didn't mention the British ML's degrees of human intelligence. Can you picture your narrative?
Yeah, so that goes with Edinburgh, which is not up there with those 4 US centers in general, but it's certainly the most prominent in Europe. Edinburgh enters the canonical story mostly in a sad way with the Lighthill Report. And that's there, particularly when I talk about the extent to which this did or didn't precipitate a broad-based winter. And the other interesting thing with Edinburgh is I believe that their group was not part of a computer science department. So that's a distinction, certainly, from the way that things develop at MIT, which doesn't exactly have a computer science department, and it's weird, but AI is definitely in with computer science in the structures that they do have. Stanford, although Feigenbaum's group is more interdisciplinary, but certainly I think Edinburgh's attempt is to make something that is somewhat more distinct from computer science and maybe perhaps more akin to what later would be called cognitive science, which is a brand that gets introduced by people who want to get back to that idea that they want to do something that actually has a connection with cognition. I think after there's the loss of faith in the idea that AI is really doing that. One of the problems I have with this is I'm trying to write relatively quickly a high-level compressed overview history. And as you yourself know from writing computer, that is a difficult thing to do in areas where there aren't secondary sources. So I wish that there were more in-depth histories of particular computer science departments, particular national AI histories and so on that I could draw on and synthesize. But those are the points at which it does enter the narrative as I currently have it.
So I have two questions. Should I ask them in succession or just one and then you answer?
I think hit me with both at once and I'll see what I
Okay.
can do.
So I couldn't help but think of, when you talked about Minsky, McCarthy, Newell, and Simons being 4, 6, 10, and 11 on the Turing Award winners, I couldn't help but think of the line from Sylvia Nazar's book, A Beautiful Mind, 1998. It was the first time I ever thought about this. The start of chapter 4 says, every prize is intimately linked to the prize committee. So I'm curious, you said that, and then you talked about the funding, how it's just this network where the MIT people just keep giving the money to the MIT people. So is that happening on the award winners? And is that still happening today?
Well, that is an interesting question. I got a little bit of visibility to that in a different piece where I was looking at the papers of Charles Barkman, who won it for the database award, and that included some deliberation. And Barkman himself ranked COD very low, COD being the second person to win it for databases for taking a much more theoretical kind of approach. So it certainly would be wonderful if we could see those things. I know the ACM records have gone to the Babbage Institute, but I kind of suspect they probably aren't going to let us see too much how the sausage is made in terms of the Turing Awards being given. The committee, I believe, tends to have some former winners on and some other distinguished people. I think there's an informal trading off between areas. So you wouldn't want to give it to a database person more than every 5 years at the, at the closest. And maybe it's more like, oh, this area hasn't won it for a long time. Maybe it's time to give them one. I did talk to some people who'd been on the committee. And one of the things they also said is they get surprisingly few nominations. And they also can only, so sometimes you get a question like, why you gave it to this person this year and then 5 years later to someone else working in the same area and didn't give it together. And they're at the mercy of how things get proposed. So also that is an element of the process. But I do think that the areas that get the awards reflect the mission of computer science to try and present itself as a serious discipline with its own theory, particularly early on. Early on, they go for AI. Then there's a big switch and they invent something called theoretical computer science. And that has won an absolutely massive share of awards for stuff about computational complexity and P equals NP. And I think, and it's kind of a hunch, but I think early on, maybe they hoped AI would play that same kind of role as the high ground theory, and it doesn't work. And instead they get theoretical computer science filling that niche, because then you just see this huge drop off in the number of awards going to AI and this big uptick in the number going to computational complexity and related things. The other thing I'll say, by the way, and it's not your question, but sorry, is I think this helps us understand why AI developed the way it did. Because AI developed within computer science, it was very natural to privilege simple processing. And it would have been weird to have gone with a statistical approach because nothing in computer science is statistical, right? At least like how it's developing, 60s, 70s, classical approaches. So the whole theoretical computer science kind of idea, the Chomsky hierarchy of grammars, the mapping of grammars to different classes of automata, I think that fits with the symbolic AI way of seeing the world in a general kind of way. And from that viewpoint, statistical approaches and neural nets are seen as being engineering, not as computer science.
Yep, my second question was, I'm really curious about this shift from, AI shifted from the academy to businesses. So was there ever a place where they were actually aligned? Like I think about pharmaceutical research, which sometimes gets done at the university level. So was there ever a time where they were actually working in alignment, or was it first MIT's Carnegie Mellon and Stanford, and then it shifted over?
I think, well, what I heard, and this is secondhand, but I was at an event in Vienna in November, and Moshe Vardi said this, I'm just quoting him, that people at MIT had said they can't afford to develop foundation models anymore. If they want to do cutting edge stuff with large language models, they have to partner with big tech companies that can build those things. And if MIT can't afford to do that, it's probably fairly safe to say no universities can afford to do that. But that's getting into the present day, and some of you probably know more about that than I do. So
yeah, I'd like to ask you, you made a prediction AI brand will not die. And you described how herding and momentum of investment is increasing. And also you described how aggregation and the apparent capability, possible abilities of this. How brittle do you think that situation is? Because aggregation risks are often brittle. And we've seen a slight indication of that from this recently from a Chinese announcement. What are your thoughts on that situation? Yeah, that's just a draft.
yeah, well, like what happens with AI in the real AI winter is that it becomes counterproductive to call what you're doing AI, and people don't. More than anything else. And AI, I argue, has made a comeback recently because of the association with science fiction. So it's been embraced by serious grown-up people running large companies because they want us to believe in a fundamentally science fiction narrative that may turn out to be true, that we are just a couple of years away from the most important thing that's happened in the history of humanity and this techno rupture.
But the investment was different. The investment source was a lot of it came from research and defense, whereas now, as you said, it's more commercial.
Yeah, it is. But I'm addressing the part of your question that said that I've said that the AI brand will not die. And I haven't said that. I've said it didn't die. I've said it came back to life. But what I will predict, and historians are always, but I'm going to go out on a limb here. If the AGI thing that there have been timelines promised so definitively does not happen within 8 years, that the AI brand will lose all usefulness and it will be tainted irredeemably with that failure. But at the same time, the systems that are developed and deployed will do lots of things. And most of the things are scary to me and bad. And, everyone cheats on their homework and disinformation, and the internet turns even more to sludge, and, customer service gets even worse and people lose their jobs. I mean, yeah, all that will happen, but it'll happen because of specific technologies. And I think if the AI brand doesn't deliver this science fiction promise this time, everyone is going to find really specific descriptive brands to describe the actual technologies, and the usefulness of grouping them all together in this science fiction wonderland of AI is going to be gone forever.
Yeah.
Yes, slightly quicker question because of the gentleman before me, because I did want to ask you about this sort of idea of the brand itself. For me, it's more like AI or die. It certainly has been in the arts and humanities recently. And because the whole idea of AI itself as a brand, what I've been seeing in the last maybe 6 months is more references to AIs. It's becoming a more pluralistic approach to language, which I think maybe the disaggregation that was being. But in terms of branding, can you just comment on the rise of the Chinese challenge in this whole area? Because obviously your book's going to come out, everything keeps changing, but I'd like to just hear your thoughts on China and the brand or the brands.
Yeah. So that kind of goes with the first one of these, right? We're being told that you need so much money, so much, I hate this word compute. Oh, and agentic, I hate that word too, right? I hate this whole language that surrounds this. But anyway, we need like so much compute, and we need so many smart people, and they are going to earn so much money that essentially the barrier to entry is so enormous that you need to be a big tech giant or funded by one in order to be a player in the space. And if all you can raise is a few $1 billion, like you're doomed, and you may as well give up now and give the money back to investors, which one company literally did. And this apparent Chinese thing that says that you can do it with a relatively small amount of money relatively easily. I mean, it would be good news for academics. Maybe MIT could have a whip round and like think about building a model again. But I can't, as a historian, I mean, what I know mostly is listening to the Hard Fork podcasts, right? I listen once a week. Those guys interview everybody. They seem to know stuff. That's mostly how I know what's going on in the present day. And the book is fundamentally about all the historical stuff. So there is a question, where should I stop? So one guy I talked to said, well, I like the book, but you shouldn't talk about ChatGPT because that's going to go out of date so fast. And I kind of see his point, but at the same time, I feel if I want to do a bit of a trade crossover thing, ideally, and have normal people actually read the book, and MIT says they're going to try that. And if someone buys a book about the history of AI and it doesn't mention generative systems and ChatGPT, they might wonder about what they think AI is connects with that. So the stuff in the present day and the GPT era, I'm really talking about mostly to distinguish it from what happened previously, rather than claiming to be the person with any unique insight into the present day developments.
Thank you very much. That's been fantastic. And I think let's thank Tom very much again.